Okay, guys, I'll started the recording here, and just to make sure that we are on the same wavelength here, there will be Wednesday 8:30 here. We'll meet here 8:30, correct? In about 2 days from now, to do the final. There is only one single final. There's not two finals. One single final ACS final exam. The final exam is 60 questions. 55 minutes. So each question is shy 1 minute, so it's about 56 seconds. And that's the reason the calculation, they might eat your time. So you have to really manage your time. The old strategy, if you are running out of time, just pick up one alphabet and then just run whatever you are missing, one single alphabet, just bubble one alphabet, correct? As I said, the stoichiometry chapter 5, that's the one is very time consuming. It will take most of the time. So you have 55, not even 60 minutes. You have 55 minutes. Anyway, let's start. And one of the topics here will come in the ACS exam. We have two topics here: how to get the pH and how to get the POH. Correct? So let's look at this one here. It says, let's see here. Identify. This is a question here. This maybe the answer here. Let me see. Did anyone had started this review at those challenging final exam review? Did you? So, for example, identify the following and as acid-base neutral solutions. So you can look at from here it is. And you can tell, so when it says sour taste, that's acidic, correct? When it says pH 4.5, that's about 5, the pH will be what? Acidic, correct? So this is acidic. Turns blue litmus paper. You have a litmus paper that's turned blue. Anytime the litmus paper turns blue, you have a base. Anytime the litmus paper turns red, you have an acid. Correct? So this is base or basic. Contains more hydronium ions than hydroxide ions. The more hydroxide ion, the more basic the solution. The more hydronium ion, on the other hand, then you have acidic. So you look at this question here and ask yourself, this one here, that's hydronium ion. And this is the OH minus. So if you have this one greater, this one lower, so then it said the solution to be acidic. Correct? Now, if the hydronium ion is lower and the hydroxide concentration, that's up, that will be basic. So what's really, we can recognize the basic solution by the concentration of the OH minus, and we can recognize the acidic solution by the hydronium concentration. So, and you can tell from here, like this question here, the HO3 plus is 3.4 10 minus 5. And you have to see if this is acidic, basic, or neutral. So, well, the pH will be minus log the concentration 3.4 10 minus 5. So how much is it, guys? By now you have to look at your calculator. I'll bring some standby calculator just in case we need them from the lab. So you know how to enter those power power of 10. It depends on calculators themselves. The calculators are, some of them they use EE, some of them they use EXP, some of them they power up. So you have to be familiar with your, so don't spend time figuring out your calculator. You can do it at home. As I said, the calculator is, all the calculators are allowed except the ones they do have what? USB. USB calculators are not allowed. So if you have one, then I will tell you to just put it in your bag or backpack, and then I will give you one from our lab. We have about 12 solar ones, so I'll give you two to use it. But you are not allowed to use one with USB. There is a risk that all the information that you have entered, I don't know. I trust everyone, but trust is not always good when it comes to final exams. So if you have any calculator that has a USB, so do not bring it for the final exam. So I will bring about 12 just in case. So what's the pH will come? Somebody has calculated this one here? 4.5. And we said, as we said, you know, this is the correct way to look at it. This is two significant figure. So I will have 2 digits after the decimal, because this is 2 sig figs. Remember that? So I have 2 digits after the decimal. Okay, and this is what, still what? 4.5, you say this goes up. That's 5.0, that's still what? Acidic, correct? So this one is still acidic. Now let's look at the second one. The second one is the OH minus is 2.8 10 minus 2. So you say the POH, in this case you have to go through the POH. Is how much is it? Minus log, same thing, because the P means minus log, 2.8 10 minus 2. So how much is this? How much is this? We are looking at 1 point what? 1.6. 1.6. This is 2 sig figs. Correct. So we have to have how many? We have to have two digits. 1.6 what? 1.55. 2 digits after the decimal. Is this the pH? No. The POH related to the pH through the relationship. Here it is. Let's look at the relationship between the pH and the POH. We did this one here. Okay, so the pH and the POH equal 14. It does not matter of the digits. It goes by the problem. So if the POH is 1.55, the pH will be, again, you have to have 2 digits after the decimal, 14.00 minus 1.55. That will be how much? 5, 4, correct? 13 will be 13, 5, 12.45. So this is what? This is 12.5, so maybe 13. This is basic. So with this one here, that will at least cover the pH. Let's look at the buffer, and then we'll go back to look at the other topics. So I will take this one out. This one is recorded, so you can check the recording. We want to cover as much as we can. So here it is. This is the pH. Now let's look at the buffer here. We have buffer here. Those who came late to the class, they're taking the section of labs with me, 030 and 028. Half of the class get an A. So if we have in the class 21 or 22, so half of that number is A. So just to let you know this, I was very happy. That's after the curve, though. After the curve, after the help. Yeah, I have to help, correct. And the same thing in the ACS exam, I have to help a little bit. So we have to polish a little bit, the curve a little bit, so helping all the students in the class. So guys, here it is. Now you tell me about the buffer. We are looking at this one here. A function of the buffer is 2. We have A, B, C, D, E. Which one? I'm not reading. You tell me the answer. E. E is not correct. We said B. Yes, B is correct. Maintaining the pH of a solution. Maintaining the pH. It does not allow the pH of a solution go up or go down. Add to a limit. It has as you go higher in chemistry, there is a capacity called buffer capacity. So if somebody will take an oral poison orally, that poison really what's happening is, depending on the amount of it, will change the pH of the blood. And the pH of the blood, the blood is the best buffer system ever. Our bloods and the animals' bloods and all the insects' bloods, this type of blood is really is a buffer, maintaining the pH of the blood solution constant. Now, if you get just small, tiny units, a human blood, I think the pH maintain about 7.14 to 7 point something, 16, something like this. So if you have a units, the 1 digits here will be changing, that can cause death. So you see how the sensitive our blood is. It's really very, very sensitive. It's neutral, but still is changing a little bit. Second digit of the pH might affect our lives. So that's depending on the poison. Somebody will take a poison. Really what the poison does, two things. One time is attacking the blood itself, the iron. Hemoglobin, like somebody will take a cyanide. Cyanide, 6 complex 6 cyano group will take iron out of the blood, blocking the oxygen to be exchanged. So a person can suffocate. Any person takes a cyanide, or just like you put a plastic bag on that person, it's suffocating. Why? Because the cyanide is blocking the oxygen exchange. That's one. Second one is just the acidity or basicity of the poison itself will affect the pH. When it's affecting the pH, the whole system is just upside down and the person will die. With the pain, but not like the pain of poison that's really attacking the blood itself, the blood construction. Blood construction, you have iron, and then the hemoglobin is 6 groups surrounding the iron 3. And if the iron 3 is picked out by the cyano group, the person cannot exchange oxygen, suffocate. It's like you putting a plastic bag on the person. So that's the answer is correct. The answer is maintaining the pH. Maintaining the pH. And the best buffer system we have in nature is the blood of insects or humans, animals. What's that? Maintain, no, not D, sorry. Yeah, you're right. Not a neutral. Maintain the pH of a solution. What did I say? No, that's wrong. Maintain the pH of the solution. That's correct. So, 157, the question of 157, in a buffer system of HF and salt NF, the HF neutralized added acid, I did not mention, and will not come up. So if you look at the buffer HF, I don't want to get into this, but this is This is the buffer here, and this is Ka of the acid. Of course, there's H2O here, and this is H3O plus. So what will happen is F minus multiplied by H3O plus, that's the Ka, that's acid constant over HF. The H2O is not part of it. This is Ka. Acid constant. Acid constant is this. When you take the log of this, minus log of this, pKa will be P and which is minus log all this stuff here. So that's the way you can calculate minus log, and then you can, before that you can isolate the proton. Hasselbalch equation, so you can have this. And what's happened is you have this ratio here is controlling the buffer. So this ratio here is, because this is constant, correct? And this is coming, the pH will come from here. So the only left is this ratio here. This ratio will control the buffer system. So that's what's maintained. So if you have an acid, if you have a base coming, the base will come and scavenge this one here. If you add base, if the poison you are taking, or you add the base from outside, the base will scavenge this one here. This Shea-Chatelet principle. The shift will be which way? Because this one will be scavenged out. Shift will be to the what? To the right. So the acid, the weak acid, has to dissociate to compensate for the H3 plus. If you have a base, that's if you have a base. If you have an acid, then the acid will add itself to the acid. If you have an acid here, the acid will add itself to here, and the shift will be which way? To this one here. This one will increase, correct? And this one here will decrease. And vice versa, if you have the blue one, if you add the base, so it will go, this one will increase, this one will decrease, and the ratio will remain very, very close. It will be not that much of a difference. So the question is, HF neutralizes added acid, okay, in a buffer system with HS. So HF neutralizes added base. HF is not necessary. The F neutralizes added H2O. The F neutralizes added base. What you can tell about this? Which one is out what I explained to you? Which one? HF neutralizes acid? No. The acid will not neutralize. The acid will be neutralized by a base, correct? So number B is the best choice you have, because if you added the base, then HF has to, because HF will scavenge this one here out, neutralizing. So HF dissociate to compensate for the H3O plus there. So B will be your choice. So this type of question, you have seen it in my lab question, if you recall. I will take this one out. 157, not this one here. We did this one here, so 158. So let's look at this. So we said this one here is, so how about this one here? What is a buffer? Oh, the buffer, the buffer makeup. Buffer makeup. You want to produce a buffer, make a buffer inside the lab. So how it's, you have two choices. One, you have to add weak acid plus its conjugate base, So like I have acetic acid, the vinegar, plus this dissociate to give you sodium, CH3 acetate, plus H plus. Of course, this one does not exist. This is hydronium ion. This one will be hydronium ion. This is one way. So what you will do, you will add this to this, the same molarity sometimes. So you'll have, depending on what the pH you are looking for, CH3 plus sodium acetate. So you have here, if you look at this, you have an acid, weak acid, and this is the conjugated base. This is acid. This is the conjugated base. This is one. The second one is to take a weak base, number 2 here, number 2, weak base plus conjugate acid. You have ammonia plus ammonium chloride. So ammonium is plus and ammonia. This is a base, and this is conjugated base. Now looking at this, yes, conjugated base is actually, it was an acid that had lost its proton, and conjugated is follower of. Conjugate means follower of. Yes, it will be it will be most of the time it's charged because it's losing the protons. It's an acid that lost its protons. So, and the conjugated acid, it's really a base that gained the proton, correct? That's what it says. So, out of this introduction review, so let's take now. I'll take this one out. As I said, that will be this review is recorded. So, what will be then the answer here in this one here? In this, we are looking at this one. What's the best one? Conjugate acid. Actually, it was a base that gained H plus. Conjugated base is an acid that lost its H plus. So, do we have an acid here? The first one, A, yes or no? No, there is no acid. Both of them are salts. Do we have the acid and base? Yes, but most of them are strong. This is strong here. Those salts here. And these are strong. Acid plus base. Both of them strong, and that's violate. That cannot be. You have a weak acid. It has to be weak acid. Well, then we have sodium chloride, sodium. This is salt and sodium strong. That's not the case. Correct? Salt plus strong base. Here, strong acid. HCl. The only left is which one? So we have carbonic acid, that's the fuzzing. Carbonic acid is CO2 gas plus H2O. That's when you have compressed in the soda can. When you open it, you hear the fuzzing. The CO2 gas is coming out of solution. So with H2O, that really is nothing less than CO2 plus H2O. You combine those together, you get carbonic acid. And then the conjugated acid of this, correct? That's would lose one HCO3 minus, and the potassium is positive. So this one here is a conjugate what? Somebody will tell me. This is a weak acid. Weak acid. So this is a conjugate what? Base, the opposite, correct? Conjugate base is actually an acid that lost. See, there's here 2H Here's one H, so it lost one of the protons. Okay, guys? So this will cover this type of buffer. Let's go and look at some other topics. So I will be jumping back and forth cover as much as I can. So let's go and look. Okay, balancing chemical equations. So you should be able to do those balancing. How about number 153? 153. Which one correctly balanced equation? Complete neutralization of calcium hydroxide, strong base with the weak acids or phosphoric acid. Which one is correct? Which one? Come on, guys. 153. We are looking at 153. We are looking at this. Which one of those is correct? Which one? Which one? I don't hear you. Make the screen bigger, I can't hear it. With your mask, I. Okay, zoom in, okay. Yeah, don't let me down. Is this coming? Yes. The answer is yes. So let me zoom in here. So that's good? Okay. Which one? Is D. Okay. The answer is, I agree? Yes, I do agree. That's the answer is D. I looked at them up quickly, so that's the answer is D. The answer is D. The answer is D. So you have to review this one here. So if you have still problems balancing chemical equations. Coming? Yes, that will come in ACS exam. So now, we'll go for molarity here. So let's see. Okay, the answer is this, D. Let's go for molarity. That's the pH. Oh, okay. So if that was not even in the lab exam, which is I did not put in the lab exam, so that's good. But in the lecture can be. So I give you this, and you have to get the hydronium ion of solution with pH of 2. What is the concentration of the hydronium? That's the question is. So pH 2, correct? That's one sig fix, correct? So our whatever we have to get, this is 1. So after the digits the pH is 1. So it looks like there is, I don't like, it has to be somehow 2.0, and then, anyway, we'll have a one pH as one sig fix. Our answer has to be one sig fix. So we are looking at this. This one has to be looking like this. Really, the hydronium ion is 2. So this has to be, we should really replace this one. This one is not existent in the solution. So pH is 2. What is the H? Concentration. And that's what or H3O plus concentration. Somebody will tell me? That's 9th grade. I think I still remember. Although my kids are grown out, but I still remember. That's 9th grade level. Correct? Remember that. You have, this P is minus log, correct? So if I have minus log X equal 2, what will be your X? What's the anti-function of the log? Power of 10. You see here, 9th grade still in the brain. 9th grade still in the brain. Okay? If I have ln, whatever ln, what's the anti-function of it? Is E. Correct? 9th grade, you still remember. That's excellent. So This is will be x will be 10 because the minus here minus what? 2. Makes sense? That's ninth grade, guys. I know it's everything is rusty, but if you go and polish the brain a little bit, it'll come back again. It will come back again. Because I remember that's the case. So it's about ninth grade, yeah. So that the minus has to come there. The minus has to come up, and it's 2. Because we have one sig fix here, and the power are not part of the sig fix, correct? So what should I do? 1. 10 minus 2. The one I just to satisfy the sig fix rules. Okay, because pH is 2, 1 sig fix. So at least I have to come up with a number here. So the answer is D. The answer is D. Everybody is following? Yes. So that might come. That might come. And here the POH is the same thing. You get the. You want me to do 151? Want to do this as well? Okay, let's do this one here. Can I take this one out? I'm taking this one out. So when it comes to the OH, always get your first. You have to go through the concentration. What is the pH of this? So what should I do? We did this one here, but I want to repeat myself. I need the pH, but there is a rule, pH plus POH is equal 14 point whatever. So I do whatever this is the case. So pH, which is really minus log, correct? So I have to get the POH. The POH here is minus log, the concentration 110 to minus 4. Correct? So 10 to minus 4 will be what? Come on, guys. That's still on. We're still on the log. Log, I think about 8, 9 grade. Still, all this. How much? 4. Yeah. You don't have to do anything because the log and the power of 10 they are inverse to each other. They are like cousins. If you go out it, you want to look at power 10, you have to you use the log as anti-function. If you want the anti-function of log, you have to go power 10. So that will be 4, because the negative with the negative will cancel themselves out. And this is just the, this is one sig fix. I will have 1 digit after the decimal, so 4, correct? So the pH will be then 14 minus the POH will be 14. Put another 0 here for 1 digit. See, it's right the digit. 14.0 minus 4.0. How much is it? 10.0. Correct? So 10.0. The answer is 10.0. Where is it? Which one? A. The answer is A. Everybody's following? Okay, good. Excellent. So let's take this one out and look at the other ones. So that's covered. Yeah, that's the molarity. Okay, so now you tell me what is the conjugate. Just quick. We'll do 146, 147. That might not come, but at least you'll have the idea. What is this and what is this? What is the conjugate base of HClO3? What's the name of HClO3? What's that? Correct. That's chloric. Perfect. Chloric acid. One word, but I just want to put them a little bit. Chloric, there is a space between chloric and acid, but this chloric is one word. But ic acid. So chloric acid. So what will be the conjugate base? Conjugate base of a chloric acid. It was originally an acid that lost what? Its proton. So will be what? Now if this is an acid here, I will take this one out. will be ClO3 chlorate, 1 negative, because this is positive 1 and the chlorate is negative 1. So it has to be this because it lost the hydrogen, correct? So this is a conjugate base. It was an acid that lost its proton, correct? Where is it? B. The answer is B, correct. So now let's just do the second one. The conjugate, I have a conjugate acid of this, H2SO4, 1 negative. I did not say conjugate base. Conjugate base was an acid that lost, but I need to see the conjugate acid of this. What's the conjugate acid? Is a base that what? Gained what? Proton. So that's conjugate base lost, and this one here, conjugate acid is gaining. Correct? Conjugate base is losing H plus, and the conjugate acid is gaining H plus. So will be H2SO4. Where is it? Where is it? C? Let me see if we can go up a little bit. Which one? Is C correct? The answer is C. The answer is C. That's correct. So if you have a conjugate base, it wasn't a base. It means it was an acid that lost H plus. Conjugated acid, it is a base that gained H plus. That's all by definition. So we take this one out, and let's look. Yeah, that's easy. It's not really difficult. Okay, so that's the most difficult part of all. So we'll do 130 and then maybe one of this percentage. So we can do 131 as well, but let's do first 129, 130, 131. This is chapter what? Chapter 5, correct? Chapter 5, that will come. Chapter 5 is a time-consuming one. So let's do 129. We have the solution is 200 mils, okay, added to 12% of potassium chloride solution. The final concentration of KCl is assumed, the volume is added, is 12%. This is a dilution law, by the way. So this is the dilution law, correct? So the dilution law, because when you dilute, you have a 12% and you added H2O to it, you have a bitter coffee, and you can add tap water to it or milk, add anything to make the bitterness out. So you are diluting the coffee solution. It's the same idea. So the dilution law is C1 V1 equal C2 V2. C is the concentration. Some textbook, they don't like C. They put it M, molarity 1, volume 1, correct? Molarity 2, volume 2. You just set it up here. So the concentration of the first one is 12%, correct? Multiply by the volume when 200 mils added to 100 mil. At the beginning was what? The volume is 100 mil, correct? C2 you don't know, or M2 you don't know. How about V2? What's the V2 will be? Yeah, let me take this one here out so you can see. So So what will be the V2? Come on, guys. 100? No. 200? No. 300. 3 what? Then now it's clicking now. That's very good. So 300 because you started when I have a bitter coffee or something, I add tap water to it, for example, or milk. So, but my volume will be not the original volume. Whatever the volume I started with, plus amount of milk or tap water I added to the coffee. So the total here, you have to watch for this. This is 300 ml. Correct? The mLs with the mLs cancels out. C2 then will be 12% multiplied by 100 over 300. So we can expect it will be less, it will be diluted, not concentrated, will be not 13% or 12%. It will be what? Less. Maybe 10%, maybe 8%, something like this, because you added what? You added more volume, more extra tap water or more milk to the. So 100%, 12 divided by 4. This is 1/4 is what? 0.25. How much is it, guys? 4%, correct? Look at this. This is 4%. So we did not look at the sig figs, but you get the idea. That's 3 sig figs, and this is 3 sig figs. This is 100. This is 3 sig figs. So your answer will be 3 sig figs. But here they give you just 2 sig figs because of that. This is the least. This is 2 sig figs. So how much is it now? 4.0. So which one? Which one? The answer is B. So when I added tap water, I decreased. I diluted the solution and the concentration will be less. Now I can drink the coffee. It's not concentrated. Are you following me here? That's what it says. So let's do 130. That's chapter 5. All of it is chapter 5. Chapter 5, the stoichiometry, the most difficult. Not really difficult, but the most time-consuming one. It takes time for these calculations here. Okay, so 130. How many moles of calcium chloride are in 250 mL of 3.0 molar of calcium chloride? So you tell me how I can approach this. I'm waiting for your inputs. So just let me know how I can start. I need moles, correct? We did this one here in the lab. Anytime I need moles and I have the molarity and I have a volume, I have to multiply the volume, the volume with the molarity to get the moles. That's it. So the only issue here I have, the molarity is mole per liter, correct? That's the unit, 3.0. However, this one here, milliliter, so I have to convert this one here, 2.50 liter. I have to convert this one here. Then multiply it by the molarity, liter with the liter cancels out. So 3.0 multiplied by 0.25, this one will be 0.250 multiplied by 3.0. The answer will be moles, because what's left is mole. How much is it? 0.7. Okay, where is the answer then will be? Answer is E, D. Okay, the answer is D. So the answer is 0.75. This is 2 sig figs. This is 2 sig figs, and all of this 2. So the answer is 2 sig figs. Okay, guys. So yes. No, the Avogadro's number always. What did I say? Avogadro. What's the keywords for Avogadro's? Keywords. Somebody will tell me. What's that? Correct. Yeah, the answer is over there. So the keywords here is atoms. Anytime I have atoms in the question, that's Avogadro's. Anytime I have molecules, those are the words here. Anytime I have ions, or sometimes called formula units, see, that's, oops, sorry. So that's, I have to use Avogadro's. Otherwise, no calculation of the mole is just normal thing, because the moles is defined. Somebody still remembers the moles? One mole is ratio between mass over molar mass, correct? And then the mole is really Avogadro's number of atoms, molecules, ions, formula units. That's what's the definition of a mole. But since we don't have this here, keywords here are not there, then I use this one here. Now, this is the general thing, but if I have the molarity here is the same thing here. Mole, I can add to this, molarity here, multiply by the volume in liters, multiply by volume in liters. So now we know that's too many definition of, this is the mole here. So the mole is molarity, which the molarity is mole per liter, by the way, mole per liter, multiplied by the volume in liter. Liter cancels out, you get moles. Okay, guys? So we have all this definition of the moles. But Avogadro's, remember, if I have atom molecules, then immediately I know that I have to use Avogadro number. Correct? So let me see. As I said, this one will come in the, you can review this one later on, but so I'm looking at, that's a deletion. Okay, let's take 127. Maybe that's, then we'll just we'll keep going on as much as we can. So this one here. Oh, sorry. Okay, guys, so here it is. How many milliliters of 25% mass over the volume sodium solution would contain 75 grams of sodium hydroxide? So I need the volume. And this is the mass over the volume. And I have mass. So what I have to set it up, the 25%, correct, equal to the definition. The mass over the volume percentage is mass over the volume. This mass of the solute, which is sodium hydroxide, volume of the solution, and the whole thing here multiplied by 100. That's your percentage. So take this one here down. So I have 25 over 100. Mass of the solute is 75 grams. Mass of the solution, I don't know. This is my X here. This is my X, correct? And this is, actually this is 25 means gram per 100 ml solution. So gram with gram cancels out. Cross multiply, I have, out of this one here, I have 25x equal to 75 over multiplied by 100. Correct, guys? So x will be 75 multiplied by 100 over 25. So how much is it? 25, 300 correct? 300 ml. Now, you have to watch, your answer has to be 300. Where is the 300? What's the answer here? Do we have a 300? No. Why? Because everything is controlled by 2 sig figs, correct? So this one here, 300 is 1 sig fig. If you put a decimal, it will be 3 sig figs. I need what? My answer has to be what? 2 sig figs. So where it will be? This is your 2 sig figs. That's 300. Everybody is following? Make sense? Make sense? Okay, that's good. It's very good. So make sense? That's because it's 2 sig figs. So let's do 128, the molarity. So this is chapter 5. It's the most time consuming chapter ever. So let's see here. Let's take this one here. What is the molarity of solution? I'm looking at 28 here. Here it is. I need the molarity. Molarity here, capital M, or that's the units. Mole per liter, or molar, means what? Mole of the solute divided by liter of the solution. Mole of the solute is mass of the solute by its molar mass. Molar mass of the solute. So this one is the top divided by liter of the solution. So the molarity of 17 grams. So I have this one here. Let's put another color so we can follow the whole thing here. I have 17 grams, correct? That will be 17 grams. Now, what's the molar mass of ammonia? Ammonia is NH3. 1 nitrogen and 3 hydrogens. Nitrogen is 1 multiplied by 14.0 gram per mole. That's the atomic mass of nitrogen is 14. Look it up. Hydrogen is 1, 3.1.0 gram per mole. So, how much is it? 17, correct? That will be 17.0 gram per mole. And how many liters we have? We have 0.50 liter. So the answer here will be, the molarity will be 17 divided by 17.0. In the top, the gram would cancel with the gram here. Gram cancels, will be the mole will come. Correct? So gram per mole, so the mole will come up here. And liter is 0.50 liter. So 1 over 0.5 half, and the answer will be is 0.5, correct? Molar, or 0.5 mole per liter, or 0.5 molar. So 3 units you have. Okay, capital M, mole per liter, or molar. So the answer is where? Is this one correct? Okay, that's good. Okay, so let's take let's see here. How many grams? This we did that, so let's go further. Solubility, yeah, that's a good thing here about solubility. Which one of the following compounds will not be soluble in H2O? I told you in the quizzes and exams, and remember last day to take the quiz 4 and exam 4 is today midnight. Everybody is listening? Today is the last day to take quiz 4 and exam 4 midnight. So plan to take it. So during our section, during our semester, we said we can use the chart and then hand it to us so we can However, inside the final exam, you will not have this chart available to you, and you cannot use it. So therefore, you have to know this chart by heart. Not every details, but at least which one is soluble, which one not soluble. So the hydroxide, all the hydroxide salts in general are not soluble, except group number 1 and ammonium. It's the hydroxide. All the sulfide, just to look at which one is soluble, which one is not soluble, because that will help you to understand. So we have the non-soluble or not soluble. Not soluble will be the hydroxide, the carbonate, sulfide, the phosphate. Okay, all those are not soluble in general. However, the exception here, they are soluble when they have group number 1, group 1 or group 1A plus ammonium. So if I have ammonium hydroxide, for example, or I have sodium hydroxide, so those are soluble because this is group 1A, this is ammonium here. So those are soluble, but all other elements will combine, a metal ion will combine themselves with those 4. They are not soluble. That's all in the chart. Then the other soluble, from the other side, the soluble one, let's say it here, soluble one, the soluble one, soluble ions here, you tell me which they are here. Let me just put another color for them. Which one? There are some exceptions, but in general, what's the soluble one? Nitrate. All the nitrates are soluble. Correct? What else? Acetate. All the acetate, CH3, COO minus, are soluble. Regardless, whatever element, metal ion you put inside with nitrate, this has to be soluble. With acetate, it has to be soluble. Then you have the exception now here, halogens. Halogens are the chloride, fluoride, the bromide, the iodide. Those are always soluble, except they have exception here. Exception when they are connected to lead or mercury or silver or mercury 1. So mercury, silver, those are not soluble with halogens. So the nitrates are soluble, the acetate are soluble, the halogens are soluble, except with those 3 elements here, they are not soluble. What else we can look at groups here? The carbonates not soluble. The bicarbonate are soluble, so the bicarbonate are soluble too. What else are soluble? Bicarbonate, nitrate, acetate, and all the rest are really, all the rest of polyatomic are soluble, except those are the ones are not soluble. So if you memorize the non-soluble, then you know all the rest of the polyatomic ions, most probably with some small exceptions, and most of the time is the lead, mercury, and silver are the case, are not soluble. But that's what the chart you want to memorize more than enough to get by. Okay, guys? You don't have to memorize all the details of it. That's the whole thing. So now you tell me now which one of the following compounds, we are looking at this, are not soluble. Which one of the following compounds will not be soluble in H2O? Sodium hydroxide? No, sodium is 1A. Group 1A are soluble. This one is soluble. Okay. How about potassium sulfate? Group 1A are everything with it soluble, like the nitrate. Lithium nitrate, all the nitrates is soluble. Halogens are all soluble except when they combine themselves with those three. Manganese is not part of those three, so it's soluble. The only thing left is the sulfide here. See here? The sulfide in general are not soluble, except if they connect themselves to 1A or ammonium. Sodium sulfate is soluble, but the other one, lead sulfide, is not soluble. This is not soluble. Okay, guys? So you might just look at the chart and memorize this very simple stuff here. You don't have to memorize details about this chart, solubility chart. Okay, guys? Take this one out. Okay, so let's go up. We did not, I'm not sure if we have covered the hydrogen bond. A hydrogen bond is a bond between, this is good to look into it, so no calculation. A hydrogen bond, we are looking at this. A hydrogen bond is a bond between hydrogen plus one of the atoms that are present. Nitrogen, oxygen, fluorine. So you have to have hydrogen on one side and one of these here, one of these atoms. Okay, guys, so for example, I have H2O. This is H2O. I have here hydrogen, correct? Can be making a bond with what? With nitrogen. So here it is. Let me take this one here out. So this hydrogen can make with nitrogen N, H, 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 and can make F, H, can make oxygen, so this one with this, okay, this one connect itself to this, and this one here connect to this, but one at a time, just one at a time. Anytime I have a combination of hydrogen with one of those atoms here, then I have a hydrogen bond, correct? I have what? I have a hydrogen bond. So now you tell me from this information what you can tell about this, from this information, what you can tell about this information. So what you can tell me about this. Let me take this one out. Now, which one will make a hydrogen bond out of this? Which of the following molecules can form a hydrogen bond? C, correct? C. Here it is. C, correct? It has a nitrogen and it has a hydrogen. Both can be connected to another molecule that has, again, is one hydrogen and then one of the atoms, one hydrogen and one of nitrogen or oxygen or fluorine. So that's about it. So let's see. Let's take further here. Gas is not covered, but okay. So which one is exothermic? Which one is an endothermic? Look at those type. Which one exo? Which one endo? Which one is exo? Which one endo? Come on, guys. Don't let me down. Which one? Which one is exo? Which one is endo? And what type of information we can get out of those graphs? Well, it looks like those are the reactants. These are the products. Correct? So, what's that? I'm hearing something whispering. Don't whisper, just say it loud. Don't whisper. Okay, so here it is. From the reactants to the products called heat of reaction. Heat of what? Reaction. So from here to here, that's heat of reaction. Okay, now from the bottom here, and you can tell me, from this information you can tell me. So from this base here of the reactant to the peak here, this is called activation energy. Energy needed to start a chemical reaction. So here it is. This is activation energy. Anytime I have the product, an exothermic reaction will always stabilize the system because it releases what? Exothermic is giving away its what? Its heat. Heat will be given off. So then if that's the case, this one here will be exothermic because the products are lower, correct? And the system is said to be more stable. It releases the heat, correct? Here is gaining the heat from the surrounding, so the heat will be what? Up. This will be what? Endothermic. And the heat is, the products are higher. Okay? So anytime the system is releasing the heat, the system is stabilized, and the product is found at lower energy, so they can be. If they are at higher energy, so they can be. It's not good for the reaction to have the product at the higher energy because this energy might be used to destroy the products themselves. Correct? So an endothermic reaction is not a stable one. So this is, the products are higher, so this is an endo. The products are lower, this is an exo. Correct? So if you get something like this, you'll be ready, correct? I did not say anything. Did I? I did not say anything. So here it is. Okay, so what are those now? Did we mention those? What's B? What's B? Come on, guys, don't let me now. Correct. So this is, B is, correct? So then energy of reactants, where are they? Reactants, where are they? A. Energy of the products, where are they? Energies of energy, where is it? D. Heat of the reaction is C. So we answered that question, correct? So if you get something like this in the exam, you'll be able to answer it, correct? So anyway, so let's see. Have it. It's recorded, so you can have it. So I'll be put it in my channel here. So the minimum energy needed for chemical reaction to begin. What is the minimum amount of energy needed to force the reaction to progress? You have gasoline in your tank of your car and you have oxygen. You think that something will happen? No, you can wait for millions of years, nothing will happen. Eventually, the gasoline will evaporate, correct? Because the temperature around the tanks may be warm, by the time it will evaporate. It won't stay for 100 years. So, but what will happen is if you provide through your ignition coils, through the spark plugs, this spark here, this is the amount, the minimum amount needed of the energy to let the reaction start. The reaction is combustion reaction, it's exothermic. It does not need the heat, correct? The heat will come off to push the piston ups and downs, correct? The energy is coming out of the reaction, combustion reaction of gasoline will be used to run those pistons ups and downs so the car will move on, correct? However, you need always, any chemical reaction, you need an activation for that. Amount, small tiny amount, just to let the reaction start. Are you following me here? That's what it's, that's the way it is. Sometimes the activation energy of a chemical reaction is so big, you need to deliver higher amount of energy. But this is always the minimum energy needed to let the reaction react. So what's the answer here? Reaction of energy, activation energy, energy of reactant, product. Which one? Okay, so the answer is correct. The answer is correct. So here is, we have still 2 minutes. Let's look. Let's set up this one here, and 4 ammonia plus 6 nitrogen monoxide give you nitrogen plus this. How many grams of NO are required to produce 140 grams of NO2 in the following reaction? So since we have grams, I will convert the grams into moles and use the advantage of the mole ratio of those molecules. You know how to set it up? Let's set it up quickly, and then you can look into this one here. How many grams of NO? We need the NO. We need the grams of the NO required to use this one here. So I started with whatever is given to me, 145 grams of nitrogen. This is given to me. I need to get rid of the grams. I use what? The molar mass. 14 is for 1 nitrogen atomic mass. I have N2, that's 28, correct? 28 grams of nitrogen per mole of nitrogen. Okay? Then I need the grams, cancel with the grams. I need to get rid of the mole of nitrogen here. 2 mole of NO. So I have 6 NO to nitrogen is 5. Correct? So mole NO2 and mole NO2 out. I need the grams of NO2. I have to use oxygen is 16 and nitrogen is 14. How much is it? So then multiply by, how much is this one here? Gram NO per mole NO. So I have how many grams is 0.300 gram NO per mole NO. Mole NO with mole NO cancels out. So you have 145 multiplied by 1 over 28, multiply this 28, multiply 6 over 5, multiplied by 30.0 over 1. And that will be the grams of NO. Correct, guys? So that's the way you set it up. Thank you very much. We'll meet Wednesday. We'll meet what time? 8:30, not 8 a.m. No, 8:30, the same like the class time. And 1 single exam. I heard that somebody say we'll have 2 exams. No. Other professors, they do 2 exams. 1 single exam. 55 minutes, 60 questions. Good luck, guys.